A very good morning to all. So, yes, we are gonna study about the immunity because we all are doctors, and the thing that we have to maintain in our life is that we have to maintain our immunity so we remain healthy for long, isn't it? So, let's start going through the immunity from Sachi. So, yeah, immunity. Every day we are exposed to large number of infectious agents. However, sorry. Every day we are exposed to large number of infectious agents. However, only a few of these exposures result in disease. Why? This is due to the fact that the body is able to defend itself from most of these foreign agents. This overall ability of the host to fight the disease-causing organisms conferred by the immune system is called immunity. Immunity is of two types: innate immunity and acquired immunity. Innate immunity is that purchased by birth. It is also called as congenital, or we can say like non-specific, non-adaptive. So here I'm going to go with acquired immunity. So it is always a pathogen specific and also develops the memory. So innate immunity is not a specific type of difference that is present at the type of the birth. This is accomplished by providing different types of barriers to the entry of the foreign agents into our body. Innate immunity consists of four types of barriers. These are physical barriers. Skin on our body is the main barrier which prevents entry of the microorganisms. Mucous coating of the epithelium lining the respiratory, gastrointestinal, and the urogenital tracts are also help in trapping microbes entering our body. Physiological barriers: acid in the stomach, saliva in the mouth, and the tears from the eyes all prevent the microbial growth. Cellular barriers: so certain types of leukocytes, WBC, of our body called like polymorphonucleoleukocytes, PML neutrophils, and monocytes, and natural killer type of lymphocytes in the blood, as well as macrophages tissue can phagocytize and destroy the microbes. WBC like polymorphonucleoleukocytes, female neutrophils, and monocytes, and natural killer type of lymphocyte, granular lymphocyte in the blood, as well as macrophages in tissues can phagocytize and destroy the microbes, because इनकी cell non-phagocytic cell होती है, but other than monocytes, macrophages, they are the phagocytic cell, and also the PML, which is the polymorphonuclear leukocytes. So all the WBCs that constitute the cellular barriers, and also we have cytokine barriers. Virus infected cells secrete proteins called interferons which protect the non-infected cells from further viral infection. So the virus infected cells has a virus over, they would just secrete a chemical and the interferon, and due to this the other cells won't get affected because they will be making their own barriers. Acquired immunity. So acquired immunity on the other hand is pathogen specific. It is characterized with the memory. This means when our body encounters a pathogen for the first time, it produces a response called the primary response, which is of low intensity. Subsequent encounter with the same pathogen elicits a highly intensified secondary or anamnestic response, that is not forgetting response. This is described to the fact that our body appears to have memory of the first encounter. The primary and secondary immune responses are carried out with the help of two special types of lymphocytes present in the blood, that is B lymphocytes and the T lymphocytes. The B lymphocytes is AMIS, means antibody mediated immune system, as CYS is actually cell mediated immunity system. So by the lymphocyte, B lymphocytes produce an army of proteins, that is antibodies, in response to the pathogens in our blood to fight with them. These proteins are called antibodies. The T cells themselves do not secrete antibodies but help the B cells to produce them. Each antibody molecule has 4 peptide chains, 2 small and light, 2 longer and heavy chains. Hence an antibody is represented as H2L2. Different types of antibodies are produced in our body. IgA, IgM, IgE, and IgG are some of them. A cartoon of the antibody is given in the figure 7.4. Because these antibodies are found in the blood, the response is also called as the humoral immune response. Means the antibody mediated response, which is say, and so we have the Antibodies have a humoral immune response, also its name. This is one of the two types of acquired immune response, antibody mediated. The second type is called cell mediated immune response or cell mediated immunity. The T lymphocytes mediate the CMI. Very often, when human organs like heart, liver, kidney fail to function satisfactorily, transplantation is the only remedy to enable a patient to live a normal life. Then a cell begins to find the same as why is that the organs cannot be taken from just anybody? What is that the doctors check? So they just say that there is no reaction. So number change would change health tissue and blood. So T helper cell signals beta plasma antibodies interchange disulfide bond intrachain disulfide bond interchain disulfide bond monomer to dimer 4 pentametal polycide is a paratop. Antigen binding site is known as the paratop. Just any source, any endothelium or any human beings cannot be made since the grafts will be rejected sooner or later. Tissue matching, blood group matching are essential for undertaking any graft transplant, and even after this, patient has to immunosuppressants all his her life. The body is able to differentiate self and non-self. The cell-mediated immune response is responsible for the graft rejection. Active and passive immunity. When a host is exposed to antigens, which may be in the form of living or dead microbes or other proteins, antibodies are produced in the host body. This type of immunity is called active immunity. Active immunity is slow and takes time to give its full effective response. Injecting the microbes ability using during immunization or infectious organisms gaining access to the body during natural infection induce active immunity. When ready-made antibodies are directly given to protect the body against foreign agents, it is called passive immunity. Now you know why mother's milk is considered very essential for the newborn infant. The alleged fluid colostrum secreted by mother during her initial days of lactation has abundant antibodies IgA to protect the infant. The fetus also receives some antibodies from the mother through the placenta during the pregnancy. These are some of the examples of the passive immunity. Vaccination immunization. The principle of immunization or vaccination is based on the property of the memory of the immune system. In vaccination, or preparation of antigenic proteins of the pathogen or inactivated weakened pathogen are introduced into the body. The antibodies produced in the body against these antigens will neutralize the pathogenic agents during actual infection. The vaccines also generate memory B and T cells that recognize the pathogen quickly on subsequent exposure and overwhelm the invaders with the maximum production of the antibodies. If a person is infected with some deadly microbes to which quick immune response is required, as in tetanus, we need to directly inject the perform antibodies or the antitoxin. Our preparation contains antibodies to the toxin. Even in cases of snake bites, the injection which is given to the patients contain perform antibodies against the snake venom. This type of immunization is called the passive immunization. Recombinant DNA technology has allowed the production of antigenic polypeptides of pathogen in bacteria or yeast. Vaccines produced using this approach allow large-scale production, hence greater availability for immunization. Example: hepatitis B vaccine produced from yeast. Means recombinant DNA technology has allowed the production of antigenic polypeptides of pathogenic in bacteria. Or yeast. Production of antigenic polypeptides of pathogen bacteria yeast. Vaccines produced using this approach allow large-scale production, hence greater availability for immunization. Hepatitis B vaccine produced from yeast. So actually by using the recombinant DNA technology, we can use any other smaller organism like microbes or yeast that multiply at faster rate to do a large amount of production of the materials, and hence we did the same the hepatitis B vaccine in which we use the yeast. And also the second question, this is the one important question, that hepatitis B vaccine is produced in large quantity by using the yeast, and the second thing is that CMIS is activated during the graft rejection. And then we have next let's cover it in the next video. Thank you for following me till here. Thank you. Have a good day.